Hello and welcome to m200 Online Statistics at Cañada College. My name is Lapuz. In this video, we will do a homework problem from section 5.3. It says that a certain TV show recently had a share of 70, meaning that among TV sets in use, 70% were tuned to that show. Assume that an advertiser wants to verify that 70% share value by conducting its own survey, and the pilot survey begins with 8 households having TV sets in use at the time of the show's broadcast. First thing they want us to do is to find the probability that all of the households are tuned in to the show. This is a binomial distribution because it has a fixed number of trials, and that would be 8 trials. The categories fall into one of two choices. You're either watching the show or not watching the show. It has a fixed probability for each trial, so each TV set had a 70% chance of being watched, and the trials are independent because we're talking about different households and we're assuming that they're not dependent on each other. So now that we know that this is a probability or a binomial distribution, we will construct a binomial distribution table. We'll remember that the number of trials was 8, there were 8 households, and the fixed probability was 70%. Let me just go back and verify that. We have 8 households and 70%. In constructing this table, I will have one column that has the random variable x and the probability column that would have the probabilities. The random variables are going to be the possible number of people watching out of those 8 households. So there can be nobody watching, 1 TV set watching, 2, etc. For this, I will just highlight the pattern and scroll down to get to as far as I need. So I went to 7, let's do one more, 8, so that's the total that we want. Now our probability distribution column will get filled in with a formula. Our formula is going to be binom, D-I-S-T, binom dist, or binom distribution. And it's going to ask for the number of successes, and that is going to be your random variable x. So I will click on this x value, comma. Our number of trials is fixed, so I can just type in 8. Our probability of successes is fixed, so I'll type in 0.7 for 70%. And cumulative, we're not looking at a cumulative distribution here. We're just concerned about the probability for each value. So I will say false. And here is our probability for having 0 people watching, 0 TV sets watching. To get the rest of this table filled in, I will click on that first cell, grab this by the lower right hand corner and drag it down all the way to 8. Now I have my distribution table. The first question they're asking is find the probability that all households, well, all households, there's 8 of them, so we really want the probability of getting 8 households out of 8. So this looks like it's going to be 0.0576. 0.0576. We need to round this off to 3 decimal places, so the third decimal place is 7, 6 is bigger than 5. We'll add 1 to 7. So our final answer should be 0.058. Now they want us to find the probability that exactly 7 households were tuned in. Probability of 7 households tuned in looks like it's going to be this number, 0.1976. 0.1976, and rounding off to 3 decimal places. 6 is bigger than 5. We will take 7 one up, and that would be 0.198. Next, they want us to find the probability that at least 7 households are tuned in. At least 7 means you get 7 or greater. So we really want to know what this value is, all filled in. Well, the simple thing to do is to add them. Down here I will just say equals, and I will click on the first cell plus the second cell. Or you can use the sum function, the SUM. But I want to show you another way to get this. We know that the cumulative distribution allows us to find anything that's equal to or less than or equal to. So let's try a cumulative distribution function. And I'll call it cumulative p of x. And let us do the same function here. Binom, dist, open parentheses. We'll hit the x value for the number of success. The number of trials is 8 again. The number, or the probability is 0.7. And now the cumulative, whether or not this is a cumulative distribution. Let's type true for this one. And when we take a look at that first one, it's exactly the same. When we click and drag this down, we see that the next one is essentially these two added together. The third one, when x is equal to 2, is adding those 3 values, etc. Notice that when you get to the very last one, it's 100%, so that's just 1. This value here, the x value, or the cumulative distribution value, 0.744, it's really the sum of these things being added together. So those two are the same. That means if I want these two values as what they were asking for, what I can do is I can take this value, which is all these numbers added up together, and subtract that for 1. Subtract it from 1, we'll say equals 1 minus, and this cumulative distribution value. And if I look at those two values here, they're the same. Well, we just want the answer, 0.2552, or round off to 3 decimal places. That would just be 0.255. We have one more part of this question. It's asking us if at least 7 households were tuned in, does the 70% share appear to be wrong? Well, there was a 0.255 chance, so it doesn't seem like it would be wrong. It seems like it would be regular. So I'll say no, because the TV show is not unusually high. This 0.225 is not an unusually high value. So it should be the answer, and that's good. I hope that helps.